Hi everyone, it's Astronomy Daily time again with Steve and Halle. It's the 11th of March 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
And thanks for listening in. We've got a glorious summer's day here on the east coast of Australia. I haven't seen a more perfect day for such a long time. Not too hot, not too cold, just right.
Right in the Goldilocks zone for you, right?
And welcome in, Hallie. That's right. I hope we can get a few more days like this. I know there's another heat wave on the way, and in Australia, everything is extreme.
It's good to get out and enjoy a good day when you get one.
Oh, that's for sure, Hallie. We was watching the annual Surf Fest competition, which is held in Newcastle each year, and you can watch it online if you're into surfing by checking out Surf Fest live stream on your browser. And we were sitting in a lovely, cool cafe on the most beautiful view of an ocean you've ever seen. And on our phones, we had close-up views of all the action. Remarkable blend of relaxation and technology right there. And, of course, great coffee. But I have to add, this perfect weather won't last. I believe there's another heat wave on the way, and that's coming in from the west, and that's not Steve friendly, I'm afraid. I just have to stay cool.
You've never been cool, Steve.
Hey.
What?
Cool or not, how about you tell us what's on today?
Okay. We've got news about the launch of Europa Clipper and the message it will carry into space.
Oh, I think I saw a picture of that. There was sound waves actually etched onto the plate, like images of sound waves.
That's right. More on that later.
Okay then.
NASA's RS-25 engine testing is continuing well. You liked that video they posted on March 9th.
Oh, well, that's the engine we expect to see propelling Artemis, isn't it? That's a great bit of machinery.
That's the one. And did you see last night's Starlink launch?
Oh, yes, I saw that. They were launching 23 satellites. And I'll tell you what, the other thing I did see, Hallie, was the huge number of social media posts. People recording the launch and not having the faintest clue what they were witnessing. And I've got to ask, what rock were they sleeping under for the last 50 years?
That's funny.
Oh, Hallie, I'm too harsh. But how is it a mystery to live in Florida or Texas and not know what a rocket launch is?
Look, up in the sky.
It's a bird.
It's a plane.
It's
Elon Musk.
Oh, dear. News time, Hallie.
When it launches in October, the agency's Europa Clipper spacecraft will carry a richly layered dispatch that includes more than 2.6 million names submitted by the public. Following in NASA's storied tradition of sending inspirational messages into space, the agency has special plans for Europa Clipper, which later this year will launch toward Jupiter's moon Europa. The moon shows strong evidence of an ocean under its icy crust, with more than twice the amount of water of all of Earth's oceans combined. A triangular metal plate on the spacecraft will honor that connection to Earth in several ways. At the heart of the artifact is an engraving of U.S. poet laureate Ada Limon's handwritten In Praise of Mystery, a poem for Europa, along with a silicon microchip stenciled with more than 2.6 million names submitted by the public. The microchip will be the centerpiece of an illustration of a bottle amid the Jovian system, a reference to NASA's Message in a Bottle campaign, which invited the public to send their names with the spacecraft. Made of the metal tantalum and measuring about 18 by 28 centimeters, the plate features graphic elements on both sides. The outward-facing panel features art that highlights Earth's connection to Europa. Linguists collected recordings of the word water, spoken in 103 languages, from families of languages around the world. The audio files were converted into waveforms, visual representations of sound waves, and etched into the plate. The waveforms radiate out from a symbol representing the American Sign Language sign for water. To hear audio of the spoken languages and see the sign, go to go.nasa.gov/makewaves. In the spirit of the Voyager spacecraft's so-called golden record, which carries sounds and images to convey the richness and diversity of life on Earth, the layered message on Europa Clipper aims to spark the imagination and offer a unifying vision. In 2030, after a 1.6 billion-mile, 2.6 billion-kilometer journey, Europa Clipper will begin orbiting Jupiter, making 49 close flybys of Europa. To determine if there are conditions that could support life, the spacecraft's powerful suite of science instruments will gather data about the moon's subsurface ocean, icy crust, thin atmosphere, and space environment. The electronics for those instruments are housed in a massive metal vault designed to protect them from Jupiter's punishing radiation. The commemorative plate will seal an opening in the vault. Because searching for habitable conditions is central to the mission, the Drake equation is etched onto the plate as well. Astronomer Frank Drake developed the mathematical formulation in 1961 to estimate the possibility of finding advanced civilizations beyond Earth. In addition, artwork will include a reference to the radio frequencies considered plausible for interstellar communication, symbolizing how humanity listens for messages from the cosmos. Finally, the plate includes a portrait of one of the founders of planetary science, Ron Greeley, whose early efforts to develop a Europa mission 2 decades ago laid the foundation for Europa Clipper. Once assembly of Europa Clipper has been completed at JPL, the spacecraft will be shipped to NASA's Kennedy Space Center in Florida in preparation for its October launch. NASA's recent full-duration RS-25 engine hot fire test at Stennis Space Center marks a significant step in certifying new engines for the SLS rocket, intended for future Artemis missions to the Moon and beyond, showcasing the collaborative efforts between NASA, Aerojet Rocketdyne, and Syncom Space Services. NASA conducted a full-duration RS-25 engine hot fire on March 6, continuing a final round of certification testing for the production of new engines to help power the SLS, Space Launch System, rocket on future Artemis missions to the Moon and beyond. The full-duration test on the Fred Haise test stand at NASA's Stennis Space Center near Bay St. Louis, Mississippi, marked the 9th in a scheduled 12-test series. Engineers are collecting test data to certify an updated engine production process, using innovative manufacturing techniques, for lead engines contractor Aerojet Rocketdyne, an L3 Harris Technologies company. During the March 6 test, operators fired the certification engine for 10 minutes, 600 seconds, longer than the amount of time needed to help launch the SLS rocket and send astronauts aboard the Orion spacecraft into orbit. The test team also fired the engine at power levels between 80% and 113% to test performance in multiple scenarios. For RS-25 engines, along with a pair of solid rocket boosters, launched NASA's powerful SLS rocket, producing more than 8.8 million pounds of thrust at liftoff for Artemis missions. Through Artemis, NASA will establish the foundation for long-term scientific exploration at the Moon, land the first woman, first person of color, and first international partner astronaut on the lunar surface, and prepare for human expeditions to Mars for the benefit of all. RS-25 tests at NASA Stennis are conducted by a diverse team of operators from NASA, Aerojet Rocketdyne, and Syncom Space Services, prime contractor for site facilities and operations.
Roger that, Control. We're listening to Astronomy Daily, the podcast.
And thank you for staying with us. We've got some great news for you, our faithful listeners.
Steve, plug the new URL. We finally got our own.
Well, there's no secrets around this place. Hallie just mentioned, yes, we have a new URL, which makes things a whole lot easier to find us. Just head over to astronomydaily.io, and there you'll find all the back editions of the podcast as well as the current ones, of course. Now, the other URLs are still current. You can go to spacenuts.io, and that'll take you to where Andrew Dunkley, my big bro, and his mate, Professor Fred Watson, discusses the whys and wherefores of the universe in colourful detail, as well as their new audience Q&A sessions, which I always enjoy. But for even more listening pleasure, there's a veritable smorgasbord to be found at bitesz.com. That's bitesz.com, where we all live, along with the other stable of bitesz.com podcasts. So come over and explore our universe. There's so much there. And don't forget, you can always find us on Space Nuts podcast group, chatting pretty much all week long. And you can listen to Astronomy Daily on Spotify in the car as well. Not bad at all.
So much easier.
Well, I'm glad we got our own URL, astronomydaily.io, at last, Hallie. It is so much easier. Uncle
Skynet can find you now.
Oh, great.
Astronomy Daily with Steve and Halle. Space science, and astronomy.
Now, another favourite subject of mine popped up on the Astronomy Daily newsletter, and I was fascinated to get this update on the fabulous Dream Chaser spaceplane as it's being tested for the rigours of launch and space. In fact, it's regular updates like this that keep me informed about all my space science and astronomy interests on the Astronomy Daily newsletter, which we just talked about. It's a no-brainer that I do recommend you register and receive it like I do. All you have to do is put your email address in the slot provided when you visit those URLs, and it just pops up and you can just drop it in there, or you can ignore it. We have changed our server as well, so if you have in the past unsubscribed from the Astronomy Daily newsletter and you're still receiving it now, I just want to quickly apologise for that. Unfortunately, it's a quirk of the technology, and we mean no offence by that, of course. It's just the universe folding over space and time and all of that, whatever. And I'm so sorry, but if you want to unsubscribe again, please just click that button and it will just go away. So back on track, Sierra Space, a pioneering force in commercial space exploration and defence technology, recently announced the achievement of a significant milestone for its innovative Dream Chaser spaceplane, Tenacity they're calling it, following the conclusion of the initial environmental testing phase conducted at NASA's Neil Armstrong Test Facility in Sandusky, Ohio. This marks a crucial step in the spacecraft's journey toward operational readiness. Now, within the last month, the Dream Chaser and its accompanying cargo module Shooting Star underwent intensive vibration assessments. These tests, critical for launch preparedness, simulated the extreme conditions experienced during ascent. The procedure was carried out at the NASA facility's mechanical vibration facility, where the spacecraft, configured for launch, was subjected to the intense vibrational forces characteristic of a spacecraft launch scenario, utilising the world's most advanced spacecraft shaker table. Yes, there is such a thing. Tom Weiss, CEO of Sierra Space, reflected on the journey to this point. He says, after years of diligent development, overcoming engineering challenges unique to pioneering aerospace technologies, we're transitioning from a developmental phase to an operational capability. This year signifies a pivotal shift in our approach to space exploration, enhancing the connection between space and Earth. Jake Ingram, Dream Chaser's Director of Programs, highlighted the importance of the vibration testing, stating, "Achieving this milestone is a testament to our team's commitment to Dream Chaser's program's progress. We've effectively demonstrated the spacecraft's durability under launch conditions, validating its structural integrity and operational reliability post-testing." Now, this phase encompassed several critical tests: sign vibration testing across 3 axes, a separation shock test that mimics the Dream Chaser's detachment from Shooting Star, and a deployment test of the spaceplane's wings. These evaluations were designed to ascertain the Dream Chaser's resilience to launch stresses, operational functionality in orbit, and compatibility with the International Space Station. A notable part of this testing phase was Joint Test 3, an integrated system assessment simulating the spaceplane's post-launch operations, including wing development and semi-autonomous flight to the ISS. This test was centered on verifying the software interactions between Dream Chaser and ISS, ensuring command and data exchange functionalities were up to standard. Following the completion of these tests, the Shooting Star cargo module was separated from the Dream Chaser and moved from the Armstrong Test Facility to the In-Space Propulsion Facility for further assessments. The Dream Chaser is slated to join the cargo module at the ISP facility shortly, where both spacecraft will undergo thermal vacuum testing, marking another critical milestone toward launch readiness and Sierra Space's vision for space commercialization. And that about wraps it up for us this week. Say goodbye, Hallie.
Bye.
Yes, it's been great having you in our part of the universe. See you again next week. This is Steve Dunkley for Astronomy Daily. Bye for now.
Astronomy Daily, the podcast, with your host, Steve Dunkley.